We spent a long time in Chapter 9 because once again I am breaking this up into two parts. We're just going to look at the factoring end in this video. So kind of like when we were factoring by using a distributive property, or I called it factoring using factoring out the greatest common factor, we're going to start off looking at what we already know. We know how to multiply two binomials. So we're going to take first times first, first times second, second times first, and second times second. So we get a product of 2x squared plus 7x plus 6. It's easy to see that, of course, we have 4 plus 3 there equals 7. 4 times 3 happens to be the same as 2 times 6. So if I had this trinomial and I wanted to factor it to look like the two binomials I started with, I want to find factors of 2 times 6, which is 12, that give me a sum of 7. And we already know where this is going. Factors of 12, we could have 1 in 12, 2 in 6, but the ones that we know that we want are 3 and 4. So we could write that as 2x squared plus 3x plus 4x. Doesn't matter what order you put the 3 and 4 in, because they're both plus. And now I have 4 different terms, and so I know I want to do factor by grouping. Okay, of course we know 3 plus 4 is 7, so we haven't changed the value of the polynomial. The greatest common factor of the first two terms is x, so what I have left is 2x plus 3. Greatest common factor of the next two terms is 2, and by math magic, no, not really magic, I have 2x plus 3 are there also. So my two factors are going to be 2x plus 3 and x plus 2. Amazing. Okay, so here we go. We want to find factors of 50, 5 times 10, to give us a sum of 27. So I could start all the way at the beginning. Oh, that didn't take long. There's my 27. Okay, I need to erase that. So I could rewrite that as 5x squared plus 2x plus 25x plus 10. Greatest common factor for the first two terms is not 5, it's just x. I'm getting ahead of myself. So then I'm going to have 5x plus 2 left. Greatest common factor for the next two terms is 5, and I have 5x plus 2 left. So my two factors are 5x plus 2 and x plus 5. Of course, it's always a good idea to check. If we multiply it back out, we get 5x squared plus 25x plus 2x plus 10, which was the 5x squared plus 27x plus 10 that I started with. I like it. So my answer was 5x plus 2 times x plus 5. Ooh, got a negative. It's okay. 24 times 3 is 72. And so we need factors of 72 that are going to give us a sum of negative 22. There's my pair. So I'm going to rewrite this as 24x squared minus 4x minus 18x plus 3. Greatest common factor of my first two terms is 4x, and when I divide that out, I'm going to have 6x minus 1. Greatest common factor for my next two pairs, well, I could take out 3, but I'm going to take out negative 3 because I want to get 6x minus 1 there also. So if I take out the 6x minus 1, what I find I have left is 4x minus 3. As always, it's always a good idea to check at least in your head. So if we FOIL that back out, we're going to have 24x squared minus 18x minus 4x plus 3, which equals 24x squared minus 22x plus 3, which is what I started with, so my factored form was correct. Now this is a nice thing to watch out for. If there is a greatest common factor, we can factor that out first. So if I factor out the 4, I have 4 times x squared plus 6x plus 8. And now I just have a happy trinomial with a lead coefficient of 1. So I'm looking for factors of 8 that are going to give me a sum of 6. So x plus 2 times x plus 4. And I'm done. I guess we can multiply it back out and make sure it works. So I'm going to distribute those two first, x squared plus 4x plus 2x plus 8. Combine them my like terms, x squared plus 6x plus 8. And if I distribute my 4, I have 4x squared plus 24x plus 32, which is what I started with, so I'm happy with my answer. This is a great tip. Always check for a greatest common factor first before trying to factor a trinomial, because if you can find one, life is good, it comes out well. It is not completely factored if you do not take out the greatest common factor. A polynomial that cannot be written as a product of two polynomials with integral coefficients is called a prime polynomial. Rats. We tried everything and nothing works. So I'm going to start this one assuming that it will work. We know it won't. We're looking for factors of negative 15 to give me a sum of 7. So I make my factor t 1 and 15, 3 and 5, and I'm done. And so I need to have one positive, one negative, so I'm really looking for a difference of 7. Okay, so your work to show, to prove that nothing works is writing out that factor t and being very sad, and then we're just going to write prime. Okay, but your work to show, to know that it's prime, is write out the factor tree, show that nothing works. In summary, when factoring quadratics in the form ax squared plus bx plus c, find two numbers m and n whose product, ac, and whose sum is b. Then write it as ax squared plus mx plus nx plus c, and use factor by grouping.